Hello everyone, I am Somalaraju Rohini from AML department studying in Savita Engineering College. In this session, I am going to explain about QR decomposition and a program to implement QR decomposition algorithm using the Gram-Schmidt method. And this is the program. QR decomposition is a method used in linear algebra to decompose a matrix into the product of two matrices. Q an orthogonal matrix and R an upper triangular matrix. It's useful in solving linear systems, eigenvalue problems, and more. Importing NumPy. We start by importing NumPy, a powerful Python library for numerical computing. We'll use it for matrix operations like dot products and norms. Defining the function. Here we define a function called QR decomposition that takes the matrix A as input. Matrix initialization. We get the number of rows n and columns m of matrix A. We then initialize two matrices Q, which will store the orthonormal vectors, and R, which will store the coefficients, making A is equal to QR. Outer loop over columns. We loop over each column I of matrix A. We start by copying the ith column into a vector U, which will be orthogonalized. Inner loop for orthogonalization. Next, we subtract the projections of U onto all previous Q vectors to make it orthogonal. We calculate the dot product of Q, J and A 0 to I, which gives the projection coefficient R, J, comma I. Then we subtract that projection from U, normalizing the vector. Once U is orthogonal to all previous vectors, we normalize it. The norm of U is stored in R of I, comma I, and the normalized vector becomes Q of 0, comma I. Printing the results. Finally, we print the orthogonal matrix Q and the upper triangular matrix R. Together, they satisfy the relationship A is equal to Q into R. Running the code with user input. This part allows the user to print a 2D matrix from the console. The eval function turns the input string into a NumPy array and we pass it to the function. You have just seen how QR decomposition works step by step in Python using the Gram-Schmidt process. This method is essential in many computational applications, and knowing how to implement it deepens your understanding of linear algebra. And this is the output of the previous program. Thank you.